first orbital class rocket, reusable rocket. And this is important because reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of space access. So we do have that entry burn coming up just about 10 seconds. Again, that will be 3 engines reigniting for just about 20 seconds or so.
Stage 1 entry burn startup.
Stage 1 FTS is saved.
There's that call out, and on your left-hand screen, you can see that those engines have ignited. Again, helping to slow down the Falcon 9 booster as it's making its way back down to Earth.
Stage 1 entry burn shutdown.
And there we heard the call out as well. As you can see that the engines have shut down. That concludes the entry burn for the Falcon booster. Coming up next in about 1 minute will be SECO. That is second stage engine cutoff. And that'll basically be where we shut down that MVAC engine and allow the second stage to coast with the payloads.
Stage 2 is in terminal guidance.
As the vehicle is making its way towards its targeted drop-off or orbit for each of the lunar landers. And just shortly after we have SECO, we'll also have the landing burn startup on the booster. So we will have a couple events happening back to back.
Stage 2 FTS is saved.
Stage 1 transonic.
For the landing burn, we reignite the center E9 engine. And again, that slows the vehicle down just in time to touch down for landing. And we have SECO 1 coming up, as well as the landing burn in just a few seconds.
SECO.
Stage 1 landing burn.
Nominal orbit insertion.
And a cool view of first stage, touching down for landing.
Landing leg deployed. Stage 1 landing confirmed.
And there you can see on your screen, the Falcon has landed on Just Read the Instructions. That marks SpaceX's 398th recovery of an orbital class rocket, and that includes first stage landings for Falcon 9 and Falcon Heavy. Now we're just waiting for confirmation of good orbit. Again, we have had SECO, that is second engine cutoff 1 for that MVAC engine. And we are just waiting to confirm good orbital insertion.
We're just in anticipation of launch.
Now let's get a closer look at the moon-bound lander. Here's Ray with an overview of Blue Ghost.
Firefly's Blue Ghost lunar lander was designed for stability. It's about 6.5 feet tall and 11.5 feet wide, so it has a low center of gravity and a wide footprint. Blue Ghost has a robust communication system with 1 X-band antenna and 3 S-band antennas that enable HD video transmission from the lander to Firefly's Mission Operations Center in Texas. The lander has 3 solar panels to help power Blue Ghost and our 10 NASA payloads during transit and on the lunar surface. For propulsion, Blue Ghost has 8 RCS thrusters, or reaction control thrusters, that Firefly designed and built in-house. These thrusters help maintain the lander's orientation during maneuvers and independently perform the final descent by pulsing for a soft landing. We have 12 attitude control system thrusters that help point the spacecraft in the right direction. These are actually the same ACS thrusters we use on our Alpha rocket and Electra orbiting vehicles. Blue Ghost has one main engine that provides high thrust for our lunar orbit insertion and braking burn prior to landing. The lander has 4 propellant tanks that carry our hypergolic fuel and oxidizer. We have 2 pressurant tanks that carry our helium. Blue Ghost is equipped with 49 struts that connect our upper and lower panels to provide a rigid structure. These struts were built in-house using the same lightweight carbon composites we use on Firefly's launch vehicles. Blue Ghost has 4 carbon composite legs and foot pads that utilize crushed core honeycomb to absorb shock and stabilize the lander as it touches down on the lunar surface. Our foot pads have contact sensors on the bottom that signal engine shutdown upon landing. We have vision navigation software that supports landing by identifying potential hazards on the moon, such as rocks and craters, before determining the safest landing site.
Firefly's Blue Ghost Mission 1, Ghost Riders in the Sky, is delivering science and technology to the moon through NASA's Commercial Lunar Payload Services Initiative. This allows NASA to buy lunar delivery services from American companies for our payloads. In turn, those payloads will help advance science exploration and the commercial development of the moon. The Ghost Riders mission includes approximately 60 days of payload operations, most of which will be spent transiting to the moon. And then those 10 NASA payloads, they'll have about 2 weeks on the surface of the moon to perform their tests, experiments, and other activities. Let's turn our attention now to the rocket that's going to help Blue Ghost get to its lunar destination. Joining us live is Jesse Anderson at SpaceX in Hawthorne, California. Jesse.
Thanks, Daryl. Last year, SpaceX was honored to launch the IM-1 mission, the first commercial lunar lander to touch down on the moon. We are excited to partner with Firefly for another NASA delivery to the moon as part of the agency's Commercial Lunar Payload Services Initiative. This is a special mission for SpaceX today because we are launching not only one, but 2 lunar landers. And we'll share a little bit more about the secondary payload in a bit. And coming soon, SpaceX will launch NASA's IM-2 Nova-C lunar lander mission, also part of the Commercial Lunar Payload Services Initiative. Also on the manifest this year are NASA's Punch and Spear X missions, as well as the return of Crew 9 and the launch of Crew 10, just to name a few. Now, it's going to be an exciting year for NASA missions.
The launch hour sequence has started.
Firefly's Blue Ghost Mission 1 marks our 8th launch of the year after a record-breaking 2024 where we launched 134 Falcon missions. Also last year, our Dragon spacecraft delivered several missions to and from the International Space Station, including 2 cargo missions, CRS-31 and CRS-30, and 3 human spaceflight missions, Crew 8, Axiom 3, and Crew 9, which is currently still docked at the station. Now, coming back to today's mission, we are now at T-minus 34 minutes from liftoff. And while the countdown continues, let's take a moment to meet the vehicle that will be taking these payloads to space today. Falcon 9 is a reusable 2-stage rocket and the first orbital class rocket capable of reflight.